Clean code isn't just about making your programs work, it's about making them last. In this comprehensive guide, I'll show you the exact practices that separate amateur code from professional software. Whether you're just starting your programming journey or you're a seasoned developer, you're about to discover the essential principles that will transform how you think about code. By the end of this video, you'll understand how to write code that your future self and your team will thank you for. Welcome to this discussion on clean code. Today, we'll explore what makes code maintainable, readable, and professional. We'll look at real-world examples, expert insights, and practical tips to help you write better code. Let's jump right in. Let's start with an outline of what we'll cover. First, we'll examine the reality of code, why it persists, and why misconceptions about its elimination are flawed. Then, we'll discuss the consequences of bad code, using real case studies to illustrate its impact. Next, we'll cover the principles of clean code, backed by expert opinions. We'll then look at professional responsibility, followed by best practices for writing and maintaining clean code. Finally, we'll conclude with the Boy Scout rule and its role in keeping codebases sustainable. Code is here to stay. It is the ultimate expression of requirements, read far more often than it is written. Even as abstraction levels rise and AI assists in coding, the need for well-structured, maintainable code remains. Misconceptions abound. Some believe code will be auto-generated, or that models and low-code platforms will replace it entirely. However, history shows that maintainability is always a concern, and even AI-generated code requires human oversight. Bad code can destroy a project. Consider this unnamed software company from the 1980s. Their product initially succeeded, gaining popularity among users. However, as complexity grew, release cycles became longer, bugs became more persistent, and performance degraded. The company eventually failed. The main culprits: rushing development, accumulating technical debt, and letting code complexity spiral out of control. This is a cautionary tale about why investing in clean code from the beginning is crucial. Messy code slows everything down. Early development may seem rapid, but technical debt accumulates, making changes difficult and increasing the risk of breaking existing features. New developers struggle to onboard, productivity plummets, and frustration grows. Development costs soar as teams spend more time navigating and fixing old issues, rather than innovating. Here's an example of messy code. It contains deeply nested conditionals, ambiguous variable names, and repeated logic. When developers encounter this, they waste time deciphering the structure instead of focusing on improvements. Poor readability leads to errors, misinterpretations, and unnecessary rework. Experts agree on what makes clean code effective. Bjarne Stroustrup emphasizes elegance, efficiency, and clarity. Code should do one thing well and be free of unnecessary complexity. Grady Booch describes clean code as readable, direct, and full of clear abstractions that maintain focus. The key takeaway is that clean code makes intent obvious, reducing ambiguity and preventing future technical debt. Here's an example of clean code. Instead of a monolithic function, we break it down into smaller, well-named methods that handle specific responsibilities. This makes the code easier to read, modify, and test. Each function has a single purpose, promoting modularity and reducing unintended side effects. Writing clean code is an art. Clarity should always take precedence over cleverness. Maintaining a consistent style, using meaningful names, and thoughtfully organizing code make it more readable and maintainable. Warning signs of poor code include excessive duplication, long functions, inconsistent naming conventions, and a mix of different abstraction levels within the same module. A true professional stands firm on quality. Think of a doctor refusing to skip hand washing before surgery. Despite time pressure, quality and precision are non-negotiable. Similarly, developers should uphold clean code standards, even when facing deadlines or resource constraints. By advocating for well-structured code, developers contribute to project longevity and success. Let's compare professional and unprofessional code. The unprofessional version lacks error handling, making it prone to unexpected crashes. The professional version incorporates validation checks, exception handling, and logging, ensuring reliability and maintainability. Proactively addressing edge cases prevents future failures. The Boy Scout rule is simple: leave the code better than you found it. Small, incremental improvements, renaming variables, extracting methods, removing redundancy, help maintain code quality. These changes may seem minor, but over time, they prevent code decay, improve team morale, and sustain development velocity. Here's an example of applying the Boy Scout rule. Initially, a function is cluttered and difficult to understand. After refactoring, it becomes concise, expressive, and easier to maintain. Small, continuous enhancements lead to a significantly better codebase. Maintaining clean code is an ongoing process. Key daily practices include regular code reviews, continuous refactoring, automated testing, and documentation updates. Cultivating a team culture that values clean code, through knowledge sharing, setting standards, and leading by example, ensures long-term sustainability. To wrap up, clean code is more than an aesthetic preference. It is a professional responsibility. Investing in code quality reduces long-term costs, improves maintainability, and accelerates development. Continuous improvement is key, and even small changes have a significant impact over time. Remember, the only way to go fast is to go well. Thanks for watching, and happy coding! Thanks for watching. Let me know in the comments if there are other topics you would like me to talk about. If you enjoyed this video, please like, share, and subscribe for more content on software engineering and technology. See you next time.